Okay, this is Chapter 3. This is stoichiometry. This is a short review for the AP Chemistry kids. And it covers Section 2, Atomic Masses and Isotopes. So, a couple of things to remember. Atomic masses are based on a standard of comparison to the isotope carbon-12. Notice, isotope carbon-12. Remember, there are two ways to write isotope symbols. Way number one is to actually write the name with a dash and the mass number of the isotope. Way number two is to write the symbol with the mass number of the isotope up there. Please remember that isotopes vary by number of neutrons only. Same number of protons, same number of electrons. The mass number is different because of the number of neutrons. All elements on the periodic table have an average atomic mass in units of AMU. AMU is a unit used to indicate a very small amount. It was arbitrarily picked by scientists. All elements on the periodic table are a calculated average. That's why there are decimal places on all the masses on the periodic table for every element. Every element is made up of the isotopes. Alright, we're going to do a very simple example. Naturally occurring copper is a mixture of two isotopes of copper. Isotope number 1 is the copper 63 isotope, and the element copper is 69.09% copper 63. Isotope number 2 is copper 65. The element copper is made up of 30.91% of copper 65. And what we're going to do is we're going to calculate the average atomic mass of the element copper. And this is real simple. And again, isotopes can be written one of two ways. Right? So you got, 63. You got two ways to write it. Alright, I made up my own little algebraic expression. The average atomic mass of an element, I'll shorten it for EL, will be the percent of isotope number 1 in abundance of that element times its mass plus the percent of isotope number 2 times its mass. And if there's a 3 and a 4, you just keep moving it on. Copper only has 2, so I'm stopping there. Our unknown is the average atomic mass of the element copper. And never leave it in percentage. Put it in decimal place. Move the decimal left 2 places. Divide by 100, whichever works for you. But it's never done in percentage. It is done in decimal. 6293 AMUs. This was number 1. And the other one was 30%-ish. 30%, and its mass was 64.93 AMU. It's nothing more than an algebra problem now. Average atomic mass of the copper, and I multiply these two guys together and I get 43.48 AMUs. So that's the mass of isotope number 1 in elemental copper. And I would expect this one to be smaller because it is the smaller percentage. And that's the mass right here. This is the mass of isotope number 2 in elemental copper. And the sum of the two gives me 63.55 AMUs. 1 atom of elemental copper is 63.55 AMUs, which if you go to the periodic table is the correct answer. Little bit tougher problem. They give me rhenium 187. They give me the percent abundance of the element rhenium, and they give me the mass of the rhenium isotope, and they want me to calculate the mass of the rhenium 185. So here's what I got staring me in the face. 3 unknowns. I need to know the average atomic mass of the element rhenium. I need to know the percent abundance of the rhenium-185. And the question is asking me for the mass of the rhenium-185. Alright, so now notice there's three unknowns. You can't do an algebra problem with three unknowns. This is what the question's actually asking you for. That means this guy and this guy have to be in the problem somewhere, have to be obtained intuitively from the problem. Average atomic mass of rhenium will be equal to the percent of isotope number 1 times its mass plus the percent of isotope number 2 times its mass. So I'm going to put in what the problem gives me, and what the problem gives me is this guy. It's telling me that rhenium-187 is 62.60% and has a mass of 186.96 AMUs. Now, again, from the problem, that's all they give me. I need something here and here. This is my unknown. That's what they're asking me for. So I'm going to make that an X. There's my actual unknown. That means that the average atomic mass of rhenium and the percent of the second isotope has to be in the problem, in your brain, intuitively gotten to. Well, the average atomic masses of the element rhenium is pretty easy. I go to the periodic table and I get the average atomic mass of one atom of the element rhenium is 186.21 AMUs. Okay. Percent of the second isotope. There are only two isotopes. 62.60% of the 187. That leaves the second one has to be 37.4%. You can only have 100% of anything. And if 62.60% is the rhenium-187, then the 37.40% must be the 185. Notice I just filled in an algebra problem, and X is my unknown. Just do the algebra. X, which is going to be the mass of the rhenium-185, and it better be around 185. Solve for X, and it comes out to be 184.95 AMUs. So what that tells you is one atom of rhenium-185 is equal to 184.95 AMUs, and it's 37% in the element.